Good afternoon everyone. So welcome back on the lecture number 6 of mole concept. Let's start. We were discussing about the concentration terms, and now we will left with the concentration terms, few concentration terms, and now we will do some questions. Initially we will practice some questions, then we will do this concentration terms on the next level. Okay, so let's try this numerical. Calculate the molarity of 2 molar urea solution which has density of 0.56 gram per ml. So we have the molality. What is the molality? Is 2 molar. What is this? 2 molar is 2 mole per kilogram. Okay, and if you have the density, now you need to find out the molarity. So molarity is number of moles, yes, upon volume of solution in liter. Volume of solution in liter. So this is the case. Now what you need to do? What you will do? So you can write this as 1 kilogram of solvent contains 2 mole of solute. 2 mole of, yes, 2 mole of solute. Now what we have? So we know that the number of moles of solute is nothing but 2 moles. Now we need to find out what? Volume. How will we find out the volume? So we just take this advantage. Number of moles equal to weight upon molecular weight, 2 mole, and we have the urea. The molecular weight of urea is 60. What is the formula of urea? NH2CO NH2. So this is the urea, dear students. So weight equal to 60. So what is the weight? 120. Now tell me, what will be the weight of solvent? Weight of, let's say, solution. So you know that solvent is 1000 gram, which is 1 kg, plus 120 gram of solute. So total weight is 1120 gram. So we have calculated the total weight of the solution. Till this point, if you have doubt, just let me know. Look into this and let me know the doubt. Is there any doubt? Okay, so let's see now if you don't have any doubt. So we have the weight of solution. Now we know the density. What is density? Density is equal to mass upon volume. So what is volume? Mass upon density. So what is mass? Mass is 1120 upon density 0.56. So this is the volume in ml. Now we know the volume and we know the number of moles. We can calculate the molarity. What will be the molarity? Let me know. Molarity will be, number of moles is 2 moles and volume is 1120 into 0.56. So which is 1.12 upon 112 and into 1000, because it should be in liter. So you need to convert into liter. So now you can solve it. You will get the answer. Okay. So I think 1 molar. Then let's see, very good question of the NCERT. Can you try it? Let's try it. How many ml of 0.1 molar HCl are required to completely with 1 gram mixture of Na2CO3 and NaSCO3 containing equimolar of both? So both have the equimolar amount. So how will you do this? Very good question. So firstly see, Na2CO3 reacts with HCl and it will give NaCl plus H2O plus CO2. So we have 2 NaCl, 2 water and this reaction. Now on the other side, how NaSCO3 will react? This will give NaCl, then H2O, then CO2. Now you can balance it. So you have H2O, you have CO2, and this is balanced. Now this is the reaction. Now it is saying that the total weight is 1 gram. Total weight is 1 gram and both is equimolar. So let's assume we have the initial mole, we have this is n mole and this is also n mole. So 1 mole react with 2 mole of HCl, 1 mole reacts with 1 mole of HCl. So total HCl is required 3 mole. So how much mole we have? This has the 2 equal moles. We have the equal moles of this. So the n mole of Na2CO3, n mole of this. So total mole is how much? Total mole is 2n. 2n mole will require 3 mole to react with this. So now this we require 3 mole of HCl in this case, and what we can do, we know the total amount. So we can just compare this with the equimolar amount of this. So we can just compare 2n number of moles into number of moles equal to 3 moles of HCl. We can just compare it and you can just calculate the Na2NaSO3 weight. Okay. Now let's see the other concentration terms. Can you try it? Try it once. Can you do it? So have you anyone done? Have you done it? Yes or no? Okay, let me give you one hint. You can just do this question by let us take Na2CO3 is x gram. So NaHCO3 will be 1 minus x gram because total is 1 gram. So now what will be the number of moles? You can just have the number of moles of this weight upon molecular weight. What is the molecular weight of this? 46, 12, 48, which is 106. And the molecular weight of this 23, 1, 12, 84. So you will have x 106, x 1 by x 1 minus x 84. You can just solve it. You will get 84x 106 minus 106x. So it will be something 296 and something like this. So you will have 10. You can just see it. The number of moles by this, number of moles by this is going to be equal because the equimolar amounts of both we have in the solution. So just solve it. Can you tell me the calculation? Can you let me the answer? What is the value of x by solving it? Let me know. So you can just add it. Okay. So it will be 106,290. Okay. This is the value of x. Let me solve for all of you. Let me solve it. Okay. I don't think so you are doing it. Uh-oh. Okay, so see it how to do. Okay, what happened? Where is this F5? Okay. Okay, so now you got the x is, what is the x? You got x is 106 upon 290. You got the value of X in the weight in this much gram. Now you can see that 1 mole of this reacts with 2 mole of HCl. 1 mole of this reacts with 1 mole of HCl. So how much HCl we require? We have, let's say, n mole, so it will be required 2n, it will be required n, so total HCl is 3n. Total HCl is 3n. So 3 into number of moles. Number of moles is equal to weight, X value, and what is the molecular weight of for the X? 106. So divide by 106, so it will be 3 by 290. 3 by 290 is the moles of HCl. Moles of HCl. Now it is saying that calculate. Can you calculate the? It is given that 0.1 molar solution molarity is given. HCl. Now you need to calculate the volume. Can you try it? Now can you do it? Just do it. Will you be able to do? Okay, can you do it? Molarity equal to number of moles upon volume. So volume equal to number of moles upon molarity. So number of moles is 3 upon 290 something into 0.1 mole. Pointed at 30, 3 by 29 something. This is something liter and multiply by 1000 something. You can solve it. So you can just try it and you will get the answer how much ml of HCl is required. Okay, so approximately 157. If I remember, it should be approximately 157 ml. Okay, so now another concentration terms. So concentration terms are parts per million, mass of solute, mass of solvent, 10 to the power 6. What does it means? If it is given 5 ppm, it means 5 gram of solute present in 10 to the power 6 gram of solution. Parts per billion, it signifies ppb, 5 gram of solute present in 10 to the power 6 gram of 10 to the power 9 gram of solution, and you can try the numerical on that basis. And similarly, there is one more important, that is the formality, number of formal unit upon volume of solution in liter. It is very similar. It is defined for the ionic solids. Ionic solids like for NaCl. For these cases we use term formality, but it is very similar to the number of moles. So the only difference, it is defined for the ionic compounds and those are for the molecular compounds. Now this is a very good question. We will do the question. Can you read it and try it once and let me know the answer? Okay, let me tell you, these 3 solution of HCl having normality 12 normal, 6 normal, 2 normal mixed to obtain the resulting solution of 4n normality. Which among the following volume is ratio is not correct for the 3 component? Okay, so we don't have the option here, so I will just let you know what should be the ratio. Okay, we will not go to the 2, what is the correct ratio, we will go to there. Okay, so let's start. We know the normality is number of gram equivalent upon volume. So we have 12 normal solution, 6 normal solution and 2 normal solution. We have the volume V1, V2, V3. Now we have added it. We have added. So number of normality, final normality will be what? Total number of equivalent upon total volume. So total number of equivalent for 1, it is equivalent, not the number of moles we are talking about here, equivalents, because it is normality. N2, N3, V1 plus V2 plus V3. Okay, so you can just calculate N1 from here is 12V1, this will be 6V2, this will be 2V3. Now add it. Now what is the normality? Normality will be 12V1 plus 6V2 plus 2V3 upon total is V1 plus V2 plus V3. This is the normality. Final normality. What it is saying, what should be the ratio of this? So final normality is 4. So you can just have 4, 12V1, 6V2, 2V3. V1 plus V2 plus V3. So it will be 4V1, 4V2, 4V3, 12V1, 6V2, 2V3. Now you can solve it. What it will be? Just send it here. All these numbers. So it will be 8V1 plus 2V2 and 4V1. It will be 4V3, which is minus 2V3 equal to 0. Now you can just take the 2 common. So it will be 8V1, 841. Oops. If you take the 2 common, it will be what? It will be 4V1 plus V2 minus V3. So what will be the ratio? V1 is the 4 times, this is single time and this is 1. So then overall sum is 0. So like ratio could be what? 1 ratio 1 ratio 5. This could be the possibility. How? You can check it. So you just multiply this by 4, and this is plus 1, 4 plus 1, 5, 5 minus 5 is 0. So the ratio is 1 ratio 5. 1 ratio 5. This will be the correct ratio. Okay. Now you can do this question. Now the another question. 25 ml of solution of barium hydroxide on titration with 0.1 molar solution of HCl gave value of 35 ml the molarity of this solution. See, barium hydroxide reacts with HCl, it will give barium chloride 2 mole and then the water. Okay, so now what information you have here? In this case, what information you have? You have 25 ml of this solution barium hydroxide titration with 0.1 molar of HCl, volume is 30 ml. So see, 0.1 molar 35, that means you have 3.5 millimoles. Now what information you have? You have barium hydroxide and HCl. 1 mole of this required 2 mole of this. I can write in a reverse way, HCl and barium hydroxide. 2 mole of this required 1 mole of this, 1 will require 1 by 2. Okay, so how much HCl we have? We have 3.5 HCl, so it will require barium hydroxide 3.52 millimoles. So barium hydroxide is actually required is 3.52 millimoles. This much millimoles you require. Now what you need to do? 3.5 millimoles if you require, what you need to do extra in this case? So in this case you need to do 25 ml of barium hydroxide and let's say molarity is M. So 3.5 by 2 equal to 25 into M. So molarity will be millimoles to millimoles cancel. It will be 3.5 2 into 25. 0.10. 7 by 100. So molarity is 0.07 molar. 0.07 molar. Now this is the next question. Very good question it is. A solution of solute X contains 40 gram of X by weight of solution. 800 gram of this solution was cooled when 100 gram of solute is precipitated. Percentage composition of the remaining solution would be. See, 40 gram that means 40 gram of X present in the 100 gram of solution. First thing is this, okay, 40 gram of X present in the 100 gram of solution. Now 800 gram of this solution was cooled and 100 gram is solute is precipitated. Okay, a solution of solute X contains 40 gram of X by weight, 800 gram of this, that means 40 gram of X is present in 100 gram. So in 800 gram X will be present into, multiply by 8, 320 gram, 320 gram, because 40 gram X is present in 100 gram. So 800 gram will contain 320 gram of X. So when it is cooled, it is precipitated 100 gram. So remove the 100 gram, it is present only 220 gram. It will left only 220 gram. And this is also then the total weight of solution is also going to be removed by 100. So 700. What is the percentage now? Percentage is 220 is present in 700 into 100. So it will be something 31.4%. Very good. So you can do it. Very conceptual question rather than based on numerical. Now this question, write the mole fraction of water in 20% weight by weight aqueous solution of H2O2. H2O2 is hydrogen peroxide. Molecular weight of H2O2 is 34 gram per mole. Okay, can you try it? Do it. Done. Okay, so 20% weight by weight means what? 20 gram of H2O2 is present in 100 gram of solution. Gram of solution. Now the mole fraction will be what? Weight upon molecular weight, weight upon molecular weight plus total weight of solution is this. So solvent, weight of solvent, weight of solvent is 100 minus 20, which is 80. So 80 upon 18. Now you can solve this mole fraction of H2O2. So this is the mole fraction of H2O2. Very simple. Now next question. Two solution of substance are mixed in following manner: 40 ml of 140 ml this and 250 of second solution. What is the final molarity? Let me tell you the question. It is saying that 480 ml of one solution, which is the 1.5 molar, and another solution is which is 250 ml and 1.2 molar. If we mixed both, what will be the final molarity? I hope you can do this question. Try it. If you have studied, just do it. If you have studied, do it. What will be the answer? Done. What you need to do? You need to find the number of moles. This is N1, this is number of moles N2. So final molarity is what? Final molarity, total number of moles upon total volume. Total number of moles upon total volume. So how will you do this? See, total number of moles and total volume is, final molarity is number of moles 480 1.5 plus 250 into 1.2 upon total volume is 480 plus 250. So now you can solve it. It will be 0, 730, now 48 into 15 plus 25 into 12, and you will get the molarity, final molarity. Can you try it? Let me know the correct answer. If you can do it, you will find it. Okay. So now this is the last question, not the last. What mass of 4% NaOH solution by mass contain 15 gram of NaOH solution? It is saying that we need to make a NaOH solution which is 4%, okay, but it should have at least 15 gram of NaOH, not more than that, of course, exactly 15 gram of NaOH. So 4% signifies that 4 gram of NaOH present in 100 gram of solution, okay. This is something. Now what we want actually at least 15 gram of this, then how much solution we will require. So we need to make the 15 gram this, then what will be the total weight of the solution. So 4 gram require present in 100 gram of solution. So 1 gram NaOH is present in 100 by 4. So 15 gram NaOH will be present in 100 by 4 into 15. So you can just solve it to 375 gram. Very easily. What you need to do? See, it is saying that the solution is labeled as 4%, but at least we want to prepare the solution which has 15 gram of NaOH. So what we need to do for that? For that, I have done this 4 gram NaOH solution. This is 15 gram of NaOH is present. So I have said this is the definition which is given. So 4 gram is present in 100 gram, 1 gram is present in 100 by 4, and 15 gram is present 100 into 15 by 4, which is the 375 gram. So we have calculated it. Now molarity of H2SO4, which is 0.58 molar, density is given. What is the concentration in terms of molality? So what is molality? Molality is number of moles upon weight of solvent. So how will you do? So 0.8 molar is 0.8 mole per liter. So 1 liter contains 0.8 mole of H2SO4. Okay, this is something. Now molality, we have the number of moles. Yes, we have the number of moles. We only want the weight of solvent. So 1 liter is the solution. 1000 ml is solution by the definition. Now we know the density is equal to mass upon volume. So total mass will be density into volume. So density is 1.06 into volume is 1000 ml. So we got actually 1060 gram of mass. This is the mass. This is the mass. Now we got the total mass. Now what you can do, just subtract the solute mass. So it will be 0.8 mole, weight upon molecular weight is 98. So weight is 98 into 0.8. So just subtract this 98 into 0.8, which will be the solute mass. Mass of solute. solute, no, it is the mass of solvent, and it is the mass of solute. Now put this value here, you will get the molality, you will get the final molality of the solution. Okay, so this is what we are doing today. If you have any doubt in any question, just let me know. Is there any doubt what we have discussed in the concentration term? Is there any doubt? So we will meet on next class. Have a good day. Best of luck.